Hello, this is Mr. Win, and this video is over solving logarithmic inequalities and finding logs without using a calculator. So, to solve a log inequality, solve it like a regular log problem, but pay attention to the inequality sign and flip it when needed. That's when you divide both sides by a negative or multiply both sides by a negative. Also, set the inside of each log to be greater than 0. That's a domain restriction. You cannot take the log of 0 or negative numbers. You must log a positive number. The answer will be the overlap of the answer and domain conditions. By the way, you must know how and when to use the conversion trick, aka the definition of logarithm. Here's the first problem. Log base 3 of x plus 5 is less than or equal to 4. So because I have one thing on both sides, I can go straight ahead and do base 3 both sides. 3 to the exponent log base 3 cancel out. This is just x plus 5. And on the right side, we have 3 to the 4th power. Now you do need to change 3 to the 4th power. 3 times 3 is 9, times 3 is 27, times 3 is 81. Now this is a basic algebra 1 problem because there's no longer logs and there's no exponents here. So I'm going to subtract 5 both sides. I get x is less than or equal to 81. Now a lot could stop here and they get it wrong. This does not mean the answer is everything less than or equal to 81. Because if you go back to the problem, look at, color size blue. Look at this. This number can't be negative. For example, negative 100 is less than 81. Can you do log base 3 of negative 100 plus 5? Can you do log base 3 of negative 95? The answer is no. So on the side, I have to do this. I say the inside, x plus 5, must be greater than or equal to 0. Not even equal to, just greater than 0. So when I solve that, I subtract 5 both sides. I have x must be greater than negative 5. That's the lowest it could be. Again, it can't be equal to negative 5 because negative 5 plus 5 is 0. It can't log 0. So we're going to combine those two to overlap. Everything bigger than negative 5 with everything less than or equal to 81. That's the and in compound inequality. So negative 5 less than x less than or equal to 81. That is our answer. Anything in there will make the original inequality true. Anything outside of that will either be undefined or it will be false. Alright, let's try another one. Log base 3 of x plus 6 is greater than 4. Alright, it's one term on both sides. I can go ahead and exponentiate both sides by base 3. Again, 3 to the exponent log 3 is gone. That's just x plus 6 is greater than 3 to the 4th power. Alright, fix 3 to the 4th power. That's 9 times 9, that's 81. And from here, I'm going to subtract 6. X is greater than 75. Again, I don't stop there. I have to look at the inside. I'm going to the inside of each log. There's only one log here. I say this inside, x plus 6, must be bigger than 0. So when I solve that, I'm going to subtract 6 both sides. I get x is greater than negative 6. Now I do the overlap of these two. This says x is everything bigger than negative 6. This other one says x is everything bigger than 75. Well, is everything bigger than negative 6 also bigger than bigger than 75? Answer is no. 10 is bigger than negative 6, but 10 is not bigger than 75. But if I go over here, is everything bigger than 75 automatically bigger than negative 6? Answer is yes, because for example, 76 is bigger than 75. 76 is also greater than negative 6. So the answer here is just x is greater than 75. So let me re-say that. If I had to draw this on a number line and see the overlap, one of them is saying start at 75, open, and go to the right because x is greater. The other one says start at negative 6. It's open and go to the right, x is greater. Where's the overlap? The overlap is literally right here. Right, so everything bigger than 75 is already bigger than negative 6 as well. So this takes it to both sections. That's why the final answer is open. It's going all this way. Alright, number 3. Log is greater than log. Alright, because there's one thing on both sides, I can go straight ahead and exponentiate both sides by base 4. I could also move it to one side and combine them through division, because it would be log minus log, and then do exponentiating. You get the same answer actually. So anyways, this one's faster though. So x plus 3 is greater than 2x plus 1. I solve for x here. I'm going to subtract x to both sides. Then I'm subtract 1 to both sides. I get 2 is bigger than x, meaning x is smaller than 2. I don't stop there. I have to look at every log and do domain restrictions. I'm gonna look at this. This is saying x plus 3 must be bigger than 0. That's one step. I'm going to subtract 3. So x has to be bigger than -3. And I'm also going to look at this. So I'll go over here. 2x plus 1 has to be bigger than 0. I'm going to subtract 1. Divide by 2. And if you do that in one step, that's fine. If you want to subtract 1 and divide 2 at the same time, you're good. Alright, so I have to find where all three of those overlap. So let's see. I'll put x first in this one. I'm going to rewrite this. This is actually the same thing as x is smaller than 2. Notice I have one thing that says x is smaller than something, and two things that says x is bigger, x is bigger. Alright, so for these bigger ones, I'd find the one that takes care of the other, again, the overlap. So is everything bigger than -3 automatically bigger than -1/2? Answer that's no, because for example, -2 is bigger than -3, but -2 is not bigger than -1/2. So I'm basically going to use this. This takes care of both of them, both of the x greater thans, and this is the only less than, so this takes care of the x less than part. I combine the two together, final answer is going to be -1/2 less than x less than 2. And you're going to draw that and do the shading and find the overlap there. That works too. If we draw all three. Let me draw that for you. The two problems are short. Alright, so we have x is smaller than 2. So at 2, we're going left. Alright, we have x is greater than -3. Let's put -3 right here. So that's open, greater shading out this way. We have a third inequality, greater than -1/2. -1/2 is between these two. Open this way. So where's it overlapping? The overlap is right here in this middle section. Alright, that's why it is open, open, shaded right there. Alright, now for the non-calculator part. To do logs without a calculator, use the properties of logs we've learned. If the problem does not come with a calculation fact, which some do, then you must rewrite the number in terms of the base given. It says find the exact value of log base 3 of 81. So then it gives a fact, so I have to change this 81 into some form of 3. So I can say, well, let's change 81. I know 81 is 9 squared. How does that help me? Does log 3 base 3 of 9 cancel out? No. So let's change 9. So it's going to be log base 3 of, this is going to be 3 squared. Alright, does that help me? The answer is yes. Let me go this way. So that turns into log base 3 of 3 to the 4th power. And actually, I can put this 4 outside if I want to. Alright, but if you see this, now you can notice we know log base 33 cancels out. This is just going to be 4. Done. You can also use property where you just bring this 4 to the front and then do 4 times 1. Same thing. Alright. You may even make an equation equal to x and convert to exponential form. So let's try that. Some people like this way more. You say this, log base 3 of 81 equals x. Now we just solve like normal. It's one term both sides. I can exponentiate by base 3. So we get 81 equals 3 to some power. I change 81. Some of y'all know right away that 81 is 3 to the 4th power, but if you don't, you can say that's 9 squared. So you get 3 to x. Well, that's still not base 3 and base 3. So we can change 9 to 3 squared. Alright, then from here, we could say that's 3 to the 4th equals 3 to the x. Y'all know when you have same bases and they equal each other, you have same powers. You have 4 equals x. But technically, y'all know that you just log base 3 both sides right now, which is the correct step to do. That's how you get rid of the 3's or ignore those 3's. Then you get 4 equals x. Alright, so the reason why we're allowed to ignore those 3's is because we're actually log base 3ing both sides. Alright, here's the other one. To do logs without a calculator, again, use properties we learned. My x one's coming down to the front. You can combine logs that are being added together by multiplying the insides, and you can combine logs being subtracted together by dividing the insides. But also the reverse. You're going to see me actually splitting this log into multiple logs. I'll break up multiplication by using addition of multiple logs. Alright, so if the problem comes with a calculation fact, which this one does, you must rewrite or split the log into a problem using the facts. So it says if log base 5 of 2 is about 0.43, and log base 5 of 3 is about 0.68, approximating the value of log base 5 of 54. So again, I have no calculator, and there's no way I can do what I did the last one. I can't change 54 into 5 to some power. But I can say, well, isn't 54 the same thing as 2 times 27? Yeah. 27 doesn't help me, so let's keep going. Let's say, isn't that the same thing as log base 5 of 2 times, let's see, 27 is 3 times 9. 9 is 3 times 3. Here you go. That should work. 2 times 3 is 6, times 3 is 18, times 3 is 54. Alright, that's going to help me. I have two options here. I can then say, alright, let's go this way. This is log base 5 of 2 times 3 cubed. Then using the reverse of the combining addition using multiplication, I'm going to actually just say that's log base 5 of 2 plus log base 5 of 3 cubes. After I combine those, what else can I do? I can use my exponent rules, bring this down to the front. Say this is log base 5 of 2 plus 3 times log base 5 of 3. And now I'm going to use substitution. So we know log base 5 of 2, they said is 0.43, plus 3 times log base 5 of 3 is 0.68. Now we just calculate that. That's pretty simple. 0.43 plus, let's see, 7, 14, 21, 2.0, what is that, 4? Alright, and then combine those two. Final answer, 2.47. That's what I got. Alright, if I erase this right here, log base 5 of 54 is about 2.47. Another option that I didn't do is, the moment I got to this step right here, I could just broke it down to 4 different logs. I should have said log base 5 of 2 plus log base 5 of 3 plus another log base 5 of 3 plus another log base 5 of 3. Because I could split that as 4 different things being added together, or I use the exponent rule to shorten my work. If you chose this option, that would have been, what, 0.43 plus 0.68 plus another 0.68 plus another 0.68, which and then will still give you 2.47. So multiple options, your choice. Alright, and that's it. Thanks for watching. Make sure you ask questions, join the live sessions. See you soon. Bye.